What if you could build your own AI QA assistant that helps you write automation tests, generate test cases, and even debug failures? And the best part, it runs completely on your laptop, costs $0, and your code never leaves your machine. In this video, I'm going to show you how I built a private AI QA assistant using Ollama, DeepSeek, and Continue.dev. And by the end of this video, you will know exactly how you can set this up for your own automation projects. AI is becoming incredibly useful for automation testers. It can help generate test cases, write automation scripts, explain complex code, and even help debug failing tests. Many testers today are already using tools like ChatGPT or Claude to speed up their work. But there is an important problem with this approach, and this is something most testers don't realize at first. When you use cloud AI tools like Claude or ChatGPT, you usually have to paste your code into the AI tool, which means your source code is leaving your system. For many companies, this creates security concerns. Some organizations don't allow sending internal code to external AI services at all. And on top of that, there can also be API costs and usage limits. So instead of sending code to the cloud, we can actually run large language models locally. This means no API costs, complete privacy, and unlimited usage. And this is where things get really interesting because with just a few tools, we can create a local AI assistant for testing and automation. To build this setup, we only need three tools. First is Ollama. Ollama allows us to run AI models locally on our machine. Second is DeepSeek, which is a powerful reasoning model that works very well for coding tasks and debugging. And third is Continue.dev. This is an AI coding assistant that runs directly inside VS Code. When we combine these three tools, we get a private AI assistant that can help with automation testing workflows. Here is how everything connects together. Inside VS Code, we install the Continue.dev extension. Continue.dev communicates with Ollama, which is running locally. And Ollama runs the DeepSeek model on your machine. So whenever you ask the AI assistant something, the response is generated locally without sending your code anywhere. Let me quickly show you a live demo of how this works in practice. First, we need to install Ollama, which allows us to run AI models locally. So I will go to the official Ollama website. Here we can see the installation instructions for different operating systems. For Mac, Ollama provides a curl command, and for Windows, it provides a PowerShell command to download and install it. So once Ollama is installed, we can start running models locally. Now I will open the terminal and run the following command: Ollama run DeepSeek R1 8 billion. So the first time you run this command, Ollama will download the model, which may take a few minutes depending on your internet speed. You will see progress bar showing the download status. Once the installation reaches 100%, Ollama automatically opens a chat interface in the terminal. From here, you can actually start chatting directly with the model. But in this video, we will use this model inside VS Code. To connect our local AI model with the editor, we need to install an extension called Continue.dev. So I will open the extensions panel and search for Continue and click install. Once the once the extension is installed, we can configure it to use our local model running in Ollama. So in the local config, we can click the gear icon and it will open the configuration YAML file. Here we can specify which model we want to use for different roles like chat, autocomplete, code editing. So in this setup, we will configure it to use our DeepSeek R1 model running locally through Ollama. Once this configuration is done, our AI assistant is ready to help directly inside VS Code. Let us now initialize the Playwright project where our AI QA assistant will write the tests. I will open the terminal and run npm init playwright at the rate latest. So now we will get multiple options and we can select the by default values for all these options and click enter to create the project. These commands create a basic Playwright project with the required structure. As we can see, Playwright has created the test folder along with an example test file. Instead of using the default test file, I will rename example.spec.ts to something more meaningful. Let's rename it to sourcedemo.spec.ts. Now we are ready to ask our AI assistant to generate the automation script. I will open the continue chat panel. Here we can see that our local model DeepSeek R1 is showing up. So here I will enter a prompt asking the model to analyze the source demo application and create a Playwright test scenario. After we submit the prompt, the model starts processing. You can actually see the thinking process here. So if we expand the thinking section, we can observe how the model is planning the automation. It starts by identifying elements on the page, and you see it is building the test script step by step. Okay, finally it is providing an option to create the test file directly in the project. So it has prepared this test file from the application. By navigating to the application, let me click create file, and as you can see, the AI assistant has now generated the test file inside our project. But it has created a new file. It has not used our source demo.spec.ts file to write the test. Okay, now let's try running the test to see how it works. I will run the Playwright test in headed mode so we can see the browser actions. Okay, the browser launches and the test begins executing. Okay, but the test has failed. It says that it is unable to locate the add to cart button. Okay, so this is actually quite common when automation scripts are generated automatically. Sometimes the locators or synchronization needs refinement. So instead of debugging this manually, I will ask the AI assistant to fix the locators and update the script. The model again starts thinking through the problem and suggests update to the script. Now I apply the changes generated by the AI. Let's run the test again to see how it works. As we can see, the scenario passes successfully. So with a small refinement to the prompt, we now have a working automation test generated by our local AI assistant. Let us now see both local AI and cloud AI. Both approaches have their advantages. Cloud AI models are usually larger and more powerful, but local AI gives you privacy, zero cost, and unlimited usage. Of course, local AI also has some limitations. Running models locally requires good hardware, and the models are usually smaller than cloud models like GPT-4. So sometimes the answer may be slightly less accurate. But for tasks like generating test cases or debugging information, they work pretty well. So today we learned how to build a private AI QA assistant for free using Ollama, DeepSeek, and Continue.dev. So this setup allows testers to generate test cases, write automation scripts, and debug tests, all without sending code to the cloud. And honestly, this is just the beginning of AI power testing. So if you are an automation tester, learning AI for testing will soon become a must-have skill. If you found this video helpful, make sure to like the video and subscribe the channel. Thank you for watching.